Hi there and welcome. This is the third video on section 5.1, a little section which doesn't seem to go with the other ones, but nonetheless it's required to go over. This is using sigma notation, so it's a notation or kind of vocabulary section. It is used in Calculus 1 to talk about areas under curves, but you'll see the sigma notation much more in Calculus 2 where you're talking about more complicated sums of things. But the goal here for this section is just to become familiar with sigma notation, what it means, how to calculate it, how to write it. So I'm going to do some examples to help demonstrate how we understand and use sigma notation. So I've written a couple of problems here, a little bit like you might see them in a book, in your book. I'm going to try to clarify, first of all, I don't really like how it's written because it's sort of hiding some of the meaning. So the first thing I'm going to do is I'm going to write the letter k equals 1 here at the bottom. So it's very obvious that that's the bottom value of k. And then the 5 is also a value of k. So instead of just writing a 5, I'm going to write k equals 5. So we're basically going through k values. And for sigma notation, we only use whole numbers. So we 1, 2, 3, 4, 5. There's no decimals or fractions for these problems, right? And then what we're counting for each of these k values is a formula, k squared plus 1. And I can even write that in parentheses because that's the function where I'm going to be inputting or sort of substituting the different values of k, so I can find out the different values of the function. So let me go ahead and do the k equals 1 to k equals 5. Again, this is counting by ones. So for k equals 1, that would be 1 squared plus 1. 1 squared plus 1 is 2. For k equals 2, I would have 2 squared plus 1. So that would be 5. And I'm going to, for each k value, I'm going to be putting it into the formula and just computing the value. 4 squared is 16 plus 1 is 17. And then I stop at 5. That would be 26. Now, of course, they're not going to write the k equals 1, 2, 3 at the bottom. That's just what I'm doing to help explain this. And you don't have to write it either, but hopefully it'll become apparent what we're doing here. The sigma notation, the sum, always represents adding things together. So we're going to be adding these numbers: 2 plus 5 plus 10 plus 17 plus 26. All right, sigma notation is always adding. There's different notations for multiplying and other kinds of operations, but this particular sigma notation is always for adding. So we basically use this formula, calculate all of the values from the lower bound to the upper bound, and then we add them together. So if we just add them together, we will get the answer to this problem. That's all we have to do. Let's see, 2 and 5 is 7, 17 and 17 is 34, 44, 54, 54, 60. So it looks to me, if my mental math is correct, this value is 60. And hopefully I've now demonstrated how to understand and calculate sigma notation. So here's where you might want to give one a try. Give this one a try right here. See if you can write it out and find the sigma, the sum of this formula. I'll just pause and then write it out. And then I'll come back and show you my answer, and you can compare it to yours if you did give it a try. All right, so the answer I got was 27. I put in k equals 2, k equals 3, k equals 4. That's what these numbers represent. I added them together, and I got a total of 27. So that's how we sort of understand and calculate sigma notation. The problems in the homework are of this difficulty. So once you understand how it works, it's a fairly straightforward process. Just plug in the numbers, add up the results, and you get the answer. There is some working backwards. So they might give you the things we're adding together and say, please write the summation, right? Write the sigma thing that represents this thing here. So they want you to write a sigma. They want you to have a starting place and an ending place. And then they want you to have some formula so that when you put in all of the numbers from the starting to the ending, you end up with this sum of those terms, right? So it's kind of a thinking backwards problem. One of the things I would do to advise on how to do this thinking backwards if you want some suggestions. A lot of it's just, kind of trial and error, either in your head or, on paper, but see the things that don't change. Log, 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 log. There's a log every single time. So I know that no matter what, I'm going to have a log every single time. What else doesn't change? There's a square every single time. So there's log and there's a square. That never changes. And the parentheses, I guess, around the square never changes. The number below the square, called the base, uh, does change. It goes from 3 to 4 to 5 to 6. A thing that changes is a variable. So we're going to use a letter, a variable, to represent the thing that changes. That's what the K is. So we're going to put a K here for the thing that changes. And then where does it start? Well, K starts at 3. So we're going to put a 3 down here as our starting K value. And it goes 1 by 1, 3, 4, 5, 6, 7, 8, all the way to 9. So we'll say K equals 9 as its ending location. And that is the answer to this question. We've written this sum out, but using sigma notation, using the sigma notation here, instead of writing out each individual thing added together. All right, well, that'll do it for this video. Hopefully that was helpful, and hopefully you have an enjoyable day, and maybe I'll see you in the next video.